All right, to summarize that previous video, we want to schedule the higher job first, the higher priority job first, and the shorter job first. So what do we do in the more general case? So when, for example, we have a job I that has a higher priority, but it also takes longer. Well, we have to do something to sort of compare jobs at that point. We can't just go with our easy cases there. We have to find some way to score our jobs and figure out which is better. So what we want is a scoring function where jobs with a bigger score are scheduled first. So I'm going to have a pause in the video here, and I'd like you to just think of some criteria. So effectively a mathematical equation that takes in that takes in Pi, Pj, Di, Dj, and it'll show you that one of these jobs should be scheduled before the other job. And you'd want to take into account what we've already learned about jobs. Alright, so we want to score the score to increase for higher priorities, and we want the score to increase for shorter times because we want those jobs to be scheduled first. So here's one possible criteria. We take the difference. So if you notice, if we increase the priority, this number goes up. If we increase the duration, this number will go down. So we have a negative number there. The bigger you make the negative number, the smaller this criteria will get. Another criteria would be, for example, taking the ratio of the two. So again, as we increase the priority, this ratio will go up. As we increase the duration, this ratio will go down. So we have two possibilities. And there are other possibilities, but these are the two we'll talk about in the slide. So let me just remind you, for the case where they have the same duration, we want the higher priority job to be scheduled first. So let's just take a look at these two metrics. We have Pi minus Di. And let's see what it has as schedule first. Well, if we take Pi minus Di, that's 2 minus 1 is equal to 1. And we would have the second job, and we would take 5 minus 1 is equal to 4. And if we're taking the first job, the higher metric job first, that would tell us to take the second job first, which we know is correct. And then same for the ratio. If we take 2 over 1, we're going to get 2. If we take 5 over 1, we're going to get 5. And so far, they both picked out the correct highest priority job, and they're going to give us a total weighted sum of completion times of 9 for both schedules. So maybe they're the same. Maybe these metrics happen to be the same. Well, that was it for jobs with the same duration. Let's look at it for jobs with the same priority and see if they agree on those jobs as well. So which job should be scheduled first? Well, we know the job that should be scheduled first is the shorter job. So we should expect these criteria to tell us that job 1 should be scheduled first. And if we take our criteria here, we would take 1 minus 3 is equal to negative 2. 1 minus 4 is equal to negative 3. And it does. So negative 2 is greater than negative 3, so we're going to schedule job 1 first, so that one gets it correct. And then the same thing over here. 1 over 3 is 1/3. 1 over 4 is 1/4. 1/3 is bigger than 1/4, so again, the schedules agree and they both come up with the same answer, the same correct answer. All right, well, next we should compare these criteria. Can we find a way to get them to disagree? So it doesn't really matter if they produce the same result. Let me rephrase that. Why does it matter if they don't produce the same result? Well, that means that for at least one instance of jobs, one scheduling algorithm is better than the other scheduling algorithm. So that's how we can tell if one metric is better than another metric. So what we're going to do is apply the two greedy algorithms and calculate their weighted sum of completion times, but this time for some jobs that differ for both the duration and the priority. So this is exercise question 4. And what I'll do is I'll break this video here so you can work on question 4, and then we'll come back and work through it together.